Hi, myself Hafiz, and my group members are Kirandeep Kaur and Prinkpal Kaur. And the topic of my presentation is in-house predictive analysis platform. So, in which we are taking a zoo as a test case, and we will discuss the post software of the zoo and the new suggested software that we have proposed in this project. We will discuss about this project. So first of all, the purpose of this presentation is to outline a strategic initiative designed to transform the zoo's operational decision making, and we aim to shift from a reactive model which often relies on guesswork to a proactive model and a data-driven approach for managing daily operations. So the previous system is a lot of gaps in the previous system, and we are going to fulfill these gaps and suggesting a new proactive system. And today I will talk on different topics. First of all, the core operational problem the zoo is currently facing, and the secondly, our proposed solution, an in-house predictive analytics platform, and at third, the business justification for this project and why it was selected over other alternatives, and at fourth level, a high level overview of the technological and project management plan we have developed to ensure its insurance, and at final we discuss about the conclusion. So first of all, I'm going to discuss about the a reactive approach to operations. Currently, the Cincinnati Zoo faces significant operational challenges. Key decisions about staffing level, food and beverages inventory, and retail stock, and based on static historical reports and manual estimation. And it creates a constant imbalance, like on a sunny day or on a sunny Saturday. The problem is that it didn't connect to the database of the weather, and when it's not connected to the weather, it cannot take the real data from the weather. Like on a sunny day it's busy, and on a rainy day it's not busy, but it cannot, this system is cannot estimate this thing. And like if it's not busy, so we can bear the cost of the stuffing and the cost of the food as well. So for this purpose we need a proactive model that should connect to the database of the weather and work on the real time. So in that slide I have discussed about the problem of the previous system. So now I'm going to discuss about the solution of the new system that was replaced to the previous system. And the solution, an in-house predictive analytics platform. And to solve this, we propose the development of an in-house predictive analytics platform. This system will be built to integrate seamlessly with the zoo's existing investment in IBM Congress. And at this heart, the problem will use a machine learning model, and the model will be fed by two key streams data. And first of all, here we will take the that yearly data of the historical attendance and the record of the visitors, and it will relate to the real-time data and daily weather forecast pulled from the National Oceanic and Atmospheric Administration Public API. And by analyzing these inputs, the system will generate accurate daily attendance forecast, and which will then be displayed on our user-friendly and dashboard on Cognos for department hand to use. And this is not just about reporting on the past, it's about using data to make informed prediction about the future. Like it will take the user of the it will use the data of the past and will predict the future. Like on a previous sunny day, it will calculate the attendance of the people, like on weeks, on months, on yearly basis. After that, with the historical real-time data analysis, it will predict the next day next day attendance, about the attendance of the visitors, and about the prediction of the weather. So all these like inputs will use at will use for the prediction of the future. And now I'm going to discuss about the project objective and benefits. The project is built around clear measurable objectives. Our primary goal is to develop a forecasting model and that achieve at least 85% accuracy, and it will be fully integrated into the Cognos dashboard and aim to deliver tangible 15% reduction in perceivable resource wastage within the first 6 months of the system going live, and the benefit extend across the organization. And financially, we financially our project on an annual basis like a cost of, you can say, $70,000, and leading to the 5-year return on investment approximately 119%. And opportunity that it means optimized staffing and linear inventory and smarter resources use. And strategically this project build valuable in-house data science expertise and creates a scalable platform that can be expands for other analytics initiative in the future. So in short, this project is beneficial in terms of the like a cost, in terms of the efficiency, and in terms of the return on investment. So using all these factors, and we will collect the data of all these factors, and these all factors showing that our project will be beneficial and we can recover our return of investment in the future. And it's a payback period very less. It means that this project would be profitable in the future.
Justification and project selection. The in-house platform was chosen over two alternatives in third-party services subscriptions and a manual Excel-based model using a weighted strong matrix. You might be asking why build it in-house instead of buying a new solution. We evaluated a project against two other alternatives, subscribing a third-party forecasting service and creating a simpler manual Excel-based model using a weighted scrolling matrix that assessed factors like buying buying a solution. We evaluated a project against other alternative strategic arguments, cost and scalability. The in-house project emerged as a clear winner with the highest score. The key reason is strategic argument bullied ourselves given a due full ownership and control over the data and the analytic platform framework, as noted by a Powerest and Fawcett in their 2013 a paper on data science. This external capacity is a circular for long-term data-driven decision-making. Furthermore, it gives a complete control over ethical consideration like data privacy and algorithm bias, ensuring a solution argument perfectly with the juice value. Project scope. The scope is tightly defined to ensure project delivery within the specified timeline and budget. We ensure we deliver the project on time and on budget. We have established a very clear and focused scope. We are committing aggregating and necessary data, developing a core prediction model, integrating with the Cognos and providing a required staff training uh, and documentation as well. Equally important is what is not in scope for a please. We will not developing dynamic ticket pricing model or integrating with model apps at this time. While these are exciting future possibilities, our immediate focus should be on delivering a robust and reliable attendance forecasting tool. Project schedule. The project is planned over a 6-month timeline from October 2025 to March 2026 and executed in a 6 distinct phases. Like from 1 October to 15 October, we have to gather all the requirements and government setup. And during the 16 October to 30 October, we have to do data cleansing, API integration and feature engineering. After that, we have to do model training, validation and achieving 85% accuracy during the period of 1 December to 31 December. After this, within the time zone of 1st February to 28th February, we have to Cognos dashboard creating a design, user training, and from the 1st March to 15 March, we have to do user training, workshops, feedback.
Let's briefly look at the technically design. The architecture is designed to be scaled and secure high profiling using a mix of exacting infrastructure and model clouding technology. Data will be pulled from two main sources, the zoo and the internal services for historical data and APs for the weather forecast. This data will be stored into centralized the postcard database hosted on Amazon Web Services. The data processing is machines learning. Modeling will be handling using a Pythons and the flow. The model has it is very if efficiency. The final productive will be the file to IBM. IBM providing a users business users, they will be need to high profiling. Now I am talking about a change and quality management. Technology alone does not graduate success. The people side of the project just as important. Our plan including a change of quality management strategy for changes of management. We will have multifaceted communication plan to the keep a stakeholder informed to enhances. We will deliver 3 formulate training workshops, each to one of trailer to the special need to operate operations, financially marketing teams with some resistance and stakeholders, which is the plan to manage by the demonstrate and system is valuable through the uh, pilot test and empowering to the changes. In conclusion, the zoo forecast is represent a portal of strategy, investment, and Cincinnati Zoo. It is a directly solve critically business problems by replacing reactive and guesswork with precision data-driven forecasting. The project is not only financially viable with the strong storage of project ROI, but it is also perfectly with the zoo and organization goal is enhancing operationally efficiency, improve the visitors experience and building foundations for the further innovations. The, these are the references. We have taken all the data from these references. Thank you.